Hey, this is Steven from LegitTechTutorials, and welcome to my first actual video of the Designing a Product series. So again, in this series we are designing a expansion module for the multistruder. The multistruder is a filament making tool, and you put in plastic pellets or recycled plastic water bottle shavings, and it produces filament for 3D printers in 1.75 3.00 millimeters or any other custom cut nozzle. So sorry about the background noise. I got the hall fan going to cool down the house a little bit. But this is going to be a live video. So what I mean by that is that I didn't prep before this. I kind of already know what I'm going to be drawing or to be doing in the CAD right now. I don't know. As I said, this is the first time I'm going to try anything like this series, so I don't know how well this is going to be as a introduction to CAD, computer-aided design. So we'll just have to see how that works out and how good of a representation it is of that. If not, I'll probably do a series about it anyways on how to do CAD for digital design for things like 3D printing or other sort of manufacturing, CNC, computer numerical control, or additive manufacturing, subtractive manufacturing, anything like that. Okay, so like I said, sorry about the noise. I'm going to try to get rid of that hall fan noise as much as I can, and also my my broken power supply whine. So what are we doing today? Today we are going to be working in Fusion 360. I use Fusion 360 for pretty much everything. It's called Autodesk Fusion 360. You can go onto their website, and it's even free for startups or for educational use. So go ahead and sign up for an educational account or whatever. I use it for pretty much everything. It's a very, very great tool. It's basically a more cut down version of a more lightweight or portable or light version of Autodesk Inventor, and I love the features, and it's very user friendly and very new, and they update it quite often. The last update was September 7th, doing optimizations and changing the workflow as far as this goes. So everything's going to be going in Fusion 360. If you guys want to use your own CAD, you can do so. If you want to use this CAD, that's fine with me. It'd be easier to follow. So yeah, so we're going to be working in Fusion 360, and we're going to be designing the roller portions. So if you can't remember what exactly the roller portions are from the last video, the roller portions are the portions that actually size up the filament. They roll over the filament as the filament rolls in between these two rollers, and then those two rollers, one roller is pinned to just rotate, is constrained to just rotate. The other pin is constrained to just go up and down as well as rotate. So the one that's going up and down is going to be riding on two sensors, two FSRs, 4-sensor resistors, that will tell the Arduino Mega brain of the multistruder what size filament it is. So what the pins are going to look like is we're going to design two of them. They're going to be identical. One is going to have, both of them are just going to be cylindrical cylinders with a ridge that goes around that the filament will ride in. Now, the idea is that we are going to design it to be 3D printed. So we are designing with the manufacturing tool in mind. So as you'll see, I didn't really do any series about CAD or 3D printing, so you'll start picking up on it on this video, that I'm going to be designing around it being 3D printed. And to be 3D printed with as little material as possible and with preferably no supports. So let's go ahead and get started. So as far as what I see in my head, I realize that it's probably best to do a revolve rather than doing a extrude upwards. And the reason being is to add the ridge halfway up. So by doing the side profile and then revolving it around the central plane, the central axis, I could have that side profile with the notch to be whatever radius I want as far as that arc is concerned. And then what I could do is I could just draw a circle that I don't extrude or don't revolve that symbolizes the filament, because the idea with the 2 pins is that the pins cannot touch if the filament's undersized. Because if they touch and it relieves pressure off the filament, it's no longer reading. So what I'm going to do is I'm going to set a standard for the filament size that it will be able to measure 1 millimeter, as small as 1 millimeter, and this is we're going to design the first ones for 1.75. The pins are going to be different from 1.75 and 3 mil filaments, which are the 2 most popular filaments. So, diameter for filaments. So 1.75 millimeter is going to be able to measure the lowest of 1 mil, and then of course the highest it'll just float, so it doesn't really matter. So, but you want it to measure at least 1 mil. Okay, so let's go ahead and get started. So what we're going to do is we're going to do a side profile on the front. So what we're going to do is go and create sketch, and we're going to create it on this side wall. And then what we're going to do is we're going to create a line here. And the line, actually, I need to go grab something. I totally forgot. It should be right here. Give me 1 second. Sorry about that. So what I went and grabbed is a great tool that I always keep with me, usually when I CAD. Obviously I forgot, but I would have done the same thing, just gone and grab it. I always keep a pair of digital or analog dial calipers with me when I'm doing CAD work. Reason being is so you could visualize how big things are when you're designing it inside the CAD software. Because you can move in and out, you know, you don't really get exactly the perspective in real life, you know, what it would look like in 3D, so you could visualize it. So what I'm thinking, and of course another thing, this has to be done in millimeters because the software that runs my 3D printer, and most 3D printers are in millimeters. Another idea of why you design around the machine. So most software 3D printers use millimeters. So we're going to design in millimeters. The software could also, you could enter in inches and it'll convert it to millimeters for you. But you got to remember that it's all in millimeters. As you see right here, units millimeters. Alright, so I'm using my digital calipers and I'm going to say that let's do some small rollers. Let's do 2-inch for right now. So let's do a 2-inch roller. And what we're going to do and then what are we going to do for diameter? So let's do like 1.5 inch diameter. So 1.5 inch diameter. See, as you see, everything's in millimeters. So there's 1.5 inch diameter. And then this is going to be, what would we say, 2 inches? Here's a 2-inch here. Oops, that's actually supposed to be 1 inch. 25.40. Or let's just say 1 inch. Okay, so there's our roller. And then another thing that we're going to do is we're going to cut. We're going to have the top solid, because what I'm going to do is we're actually going to cut channels in it to remove some of the weight, and so that being the material that will need to be used in the additive process. And also it takes less time, generally speaking, of course, if you have your shells, your perimeter shells. And that's why, like I said, very important to design around what machine. Figure out before you start designing what machine you're going to manufacture it on. Because if it was subtractive, I probably don't want to do this. If it was CNC out of plastic, this is going to add a whole bunch of time. Because I start out with a big cylinder, and then I don't want to hone all the pockets out. And even at 2 inches, you know, you have to account for how big the bit is, and if the bit could go down in there and all that kind of stuff. So, you know, you want to design around, you know, what you want to design around what machine you're going to do it on. And of course, I could have done, you know, a square right here, and then just cut the ends out, but you get the idea. Now it's all you know, this guy should coincide with that line, but, and then let's just draw, yeah, so I could have done a square. And then this will stay there. Alright, so now that we got that, what we'll do is we'll go ahead and revolve it. We'll stop the sketch, and we'll revolve these two profiles around this axis. Alright, so there you go. So there it is. Now what we're going to do is we're going to go back into our edit sketch, and I'm going to put that crease right in here. Now what I'm going to do is I'm going to draw, okay, so what did I say? I said it needs to do at least 1 mil filament. So that's 0.85. So what I'm going to do is we're going to find out how far away from the center line does it have to be to measure 1 mil out. 0.8, what is it? 0.85. Okay. So now let's just have that line there. That line's going to establish our and then this is 1.75 millimeter filament. Okay, so there's our filament. 0.875, barely touching, right? So there's our filament, and if you could imagine, there would be another roller right here as that filament pinches in. And there you go. So what I'll do is I'll only revolve these two geometries and leave this hollow, so I'll leave that ridge there with that circle. And let's go ahead and take a look at what that looks like. So what I need to do is go back to this, and then oops, I selected it. You don't do that. And then edit feature, and then what I wanted to not do is I don't want it to do those two, which I'm hitting control, by the way, to undo that. And there you go, there's the ridge. So now I could go back whenever I want, because it's all parametric editing, or whatever the I think it's parametric or something. So now I could always go back and change this, and it will edit that particular ridge all the way around. But I think that's good for right now. We'll do the calculations on it later. Okay, so now what we're going to do is on the top, we're going to create our next sketch here. And what I'm going to do is I'm going to first do an offset to figure out how thick I want to do it. And of course, like I said many times, you're designing for the machine, so you don't want to go too thick, because I'm going to be doing this in PLA plastic, and PLA plastic is very strong. Very rigid, but not very ductile. So we don't really have to worry too much about the thickness. Again, I have my digital calipers, so if I have any questions about like how thick I actually want something, I can look at my digital calipers. I could say, okay, 10 too much, 5 would probably be okay, 7.5 that's pretty good. Negative 7.5 millimeters. So there we go, there's our offset. So again, we're going to be drilling in, and then now what we're going to do is we want to do our little braces that go across to brace the side. Not like you really need to, but it's good. So we're doing a center rectangle, and then we're going to go off to the side until it clips, and then the thickness. Is a little dinky. Let's go 7.5 again. 7.5 might be a little small, but it's fine. And then just wherever it clips is where it clips. That's fine. Wherever it clips the edges, you see, obviously not going to be perfect there, but that's fine. Okay, and then we're going to do it again. And again, 7.5. 7. Ooh, I got pretty close. Alright, so now all we have is just this drawing on top, and then what we're going to do is we're going to extrude it back down through 2 inches. So we're going to go create, extrude, and we're going to extrude now we're going to cut. So it's a subtractive process. We're going to cut out those, and I'm just going to go here and then drag down, and it's 2 inches basically. Negative 2 inches. Negative 2 inches. And it's set to cut distance, or you could do through all to this face, or to face. There you go. Now, no matter what happens, it'll do that. And now at the top, you see that we have this cut. Now, another thing that we're going to need to change on that particular drawing is that these ideally are going to have a bearing in there. So they're going to ride on a bearing. The bearing is going to be inside the wheel. And also a shaft needs to go through there. The drive shaft needs to go through there. You know, a pin, right? I mean, you don't necessarily need to do a pin, but that's, you know, the easiest way I thought about it. So what we're going to do is going to go back, edit sketch, and then now whether or not we're going to do a 3D printed bearing. I haven't really tested too much 3D printed bearings. I will be for this project. Or we're going to do a steel bearing. So a steel race and steel balls, and then the other one's plastic race and plastic balls. And of course, just rotational, not actual, not thrust bearings or anything like that. So what we're going to do is we're going to add another circle there with a center diameter, and what we're going to do on that is make it a nominal size. You know, say 1/16, something like that. You know, a nominal inch size. So let's do it like 5/8 was at 6.25. Yep. 6.25. 6. We can do a half inch. Half inch. Let's just do a half inch. 0.5 inch. And there is our race. And then another thing that we're going to want to do on this guy is that, sorry about that, cat wants to get it. Give me 1 sec. Alright, back, sorry about that. So what that's going to be is it's going to be a little shoulder that it's going to go down onto. So what I'm going to want to do is I'm going to want to extrude those pieces down. Sorry about that, my cat's going crazy. Okay, so I'm going to edit that sketch, and then what I need to do is I need to push this down, and then another thing that I need to do is I need to make that shoulder. So what I need to do is I need to create another offset and then figure out the thickness of that shoulder. Offset, 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 offset. Am I editing sketch? Okay, I'm editing sketch. I just used it before. There it is. Okay. And thinking of the thickness. 5 mil. Let's just do 5 mil for right now. 5 mil. All right. There we go. And then we're going to go back into sketches, turn on that second sketch, create, extrude, this. So these are going to be extruded downwards. So we're going to have to do 2 extrudes, because these are going to be pushed, and then these are going to be extruded downwards. Let's just do 5 mil. Okay. And then these are going to be pushed out pretty much. Yeah, these are going to be pushed out. And then I need to put a bottom on it. And then that's going to be on both sides. Okay, So let's go ahead and we extruded. We are going to extrude again. Sorry about that. Cat's freaking out. Okay. I'm gonna cut. Oops. Okay, so there's a little bearing race, right? And obviously the shaft is going to go all the way through, so we're gonna have to draw another circle on here. Oops. I didn't want to do that. And then this is going to be circle shaft. The shaft is circle. And let's just say so what size circle do we want? We'll probably do, how big was the other circle we did? Probably about, because this is going to be 3D printed, so we can do kind of whatever size we want. But the other one could be, you know, let's do 0.3 inches. Okay. And then we'll just go ahead and cut that. Actually, yeah, we'll just have it hit the side of the box here, which that's fine. So then we'll go back, extrude. Sorry about that. My cat's really large. She came in and then she wanted to go out. Okay. So we're going to extrude this guy all the way down. Distance to here. Okay. Alright, how's that looking? It's looking good. And of course this circle, if I use a steel ball bearing, it's going to need to be if I use a steel ball bearing, it'll have to ride against this side wall, and then I'll have to choose the center diameter that's with the steel ball bearing, the steel ball bearing, and steel race. But in this case, we are using in this case we'll probably use a 3D printed ball bearing instead, because keeps cost down and it'll be kind of cool. So now another thing that we're going to do is we're going to do the exact same thing on the other side. Sketch, create sketch. Oops. Okay. Create sketch here. Then what I'm going to do, hit here, project include, project this, and that. And then what I'm going to do is do the exact same geometry. So I already have those circles. So what I'm going to do is I'm going to go ahead and extrude again. Extrude this. Oops. Not that, and that. I believe I did 5 mil. Something like that. Alright, 5 mil. 5 mil. And of course, this is just roughing it out. We're going to be going back through all this stuff and re-editing it again to get exactly what we need as far as you know, getting the right things for what we ordered. And yeah. So then what we're going to do is we're going to extrude that down also 5 mil. So now we got the bearing race. We got the bearing race. It doesn't have anything on the bottom. I mean, we don't really need anything on the bottom. I mean, it's got a bottom, theoretically speaking. You know, I'm not too worried about that. I probably wouldn't even fill that in. All right. I mean, you can fill it in by going back through and extruding this circle all the way down, or extruding this face all the way down. All right, so we have our little we have the runner here with everything roughed out. You know, this groove will be optimized. The depth and the circumference of the bearing circle will also be configured, whether we're using a metal ball bearing with a metal race, or we're using a completely 3D printed arbitrary whatever size we want type of bearing and race. So this will also be duplicated, and then we will also design the shafts that will ride in the brackets. We also need to design the brackets that will hold these guys, that'll attach to, what is it, I think it's 5/8, a 5/8 piece of steel steel square tube. And to be able to ride up and down, and then we need to design the little sockets for the pressure sensor for the FSRs to go into. And yeah, and then also this needs to be arbitrary to be able to slide up and down anywhere on the 5/8 to get the ideal distance away from the hot end. And yeah, so there is a little roller. All right, so seems to be we'll see if I can continue to do the non-practiced videos. This one went pretty well, you know. Besides my cat freaking out, she's still kind of freaking out. It's kind of annoying, but I like the kind of impromptu. But I might practice some of them. I might not practice others. When I mean practice, I mean do it in another file and then come back and do the exact same thing. But yeah, I really am excited for this series. I'm really excited to continue. Again, I am not I'm not the best designer in the world. I am relatively new at this stuff, and I believe that everybody kind of is until they've designed everything, which nobody ever designs everything. So yeah, main things to take away at the beginning, if you're starting to design some stuff, is design towards what you're going to use. Uh-oh, it seems like did I cut everything out? No, everything's good. Okay, design for the type of machinery you're going to use. Have a digital caliper sitting at your side in order to visualize different dimensions and thicknesses of supports and stuff like that, and then how bearings work. And think of what's going to go in there, and whether or not you need millimeters nominal, and whether or not you would be able to find special ones at low volume, or you'd have to order them from China especially, or if you're going to 3D print them, etc., etc. Because as you see, I designed this specifically for 3D printing. And also another point that you might notice is that in order to be better at 3D printing, I should probably get this guy and bring this guy all the way down to here. So get these two to touch here. So that will be added because this is floating right above the bottom. Or another thing that I could do is have it just extruded all the way, which is not actually that bad of an idea. So I'll probably just have it extruded all the way up. Easier to do rather than modeling it to where it's got an organic shape and touches that sidewall. Alright guys, so please subscribe for more videos in this series and other series as well. And I hope you guys liked the video, and I will see you guys in the next